So chapter 2 is going to be about chemistry. So chapter 2 is about matter and atoms and how atoms make molecules. And we care because you are molecular. You're comprised of many, many macromolecules, which makes up what comes above molecules. Organelles, which comprise cells, which why are cells so magical and wonderful? That's where you have life and you're in biology. So organisms are comprised of matter, and that's anything that takes up space and has mass. And when we talk about matter, we're looking at elements, which are substances that cannot be broken down to other substances by chemical reactions. So if we talk about an element, that's where you can, in your mind, picture the periodic table. That's a whole table of elements. Give me some examples of elements. Carbon, oxygen, nitrogen, silver, gold, not biological, but right, all of those are elements. If you try to break carbon down, you can't chemically. Okay, now, if you wanted to break carbon down, those of you are thinking, well, yes, you can. What could you do with carbon? How could you break it apart? You could break it apart into subatomic particles, right? And what are those subatomic particles? Neutrons and electrons, but that won't happen with a chemical reaction. Okay, so when we talk about an element, something that's not going to be further broken down by a chemical reaction. We're going to contrast this to a compound. A compound is going to be made up of two or more elements in a fixed ratio. Give me examples of compounds.
Water.
Salt. And what?
Water.
Water. Okay? So if we look at a compound, can I break a compound down? Can you break water down chemically?
Yeah.
Well, what does water break down into?
Hydrogen and oxygen.
Hydrogen and oxygen. Can you break down hydrogen and oxygen chemically? No. So that means now we're back down at that elemental level. Okay? And when we talk about a compound, there's a number of things that you want to make a note of as you're thinking, okay, how am I going to know what a compound is? Actually, how many of you make lists? Okay, so you might have to your margin write down the word compound, and what would you write down as a list of things that you're going to look for to recognize the word compound? Okay, so we have two or more elements. I should say two or more elements.
Fixed ratio.
Fixed ratio.
Different characteristics from this.
Okay, different characteristics from the elements. Does anybody recognize a theme there?
Emergent property.
That's emergent properties. So your different characteristics than elements. And you can make a note that that's an emergent property. Example. Okay. It's a good idea when you see something where there's a number of things that describe that word. If you list it out at the margin, it will draw your attention to it when you're reading it. Be less likely that you'll skip over it. So if we look at water, let's prove that water is a compound. What is water made up of? Hydrogen and oxygen. So does that qualify as being two or more elements? Yes? Okay. What does fixed ratio mean? Can't change it? So what is the formula for water? H2O. What if you went out and you ran and I offered you H2O2? Still hydrogen and oxygen. Is it hydrogen peroxide? Does that sound tasty? No? So is there a fixed requirement to be water? Yeah, and that ratio of hydrogen to oxygen can't change. That's what we mean by a fixed ratio. If you change the number of atoms in the compound and that changes the emergent properties, then that is the definition of a fixed ratio. Does water have different characteristics than individual hydrogen and oxygen atoms? Yes? So we would agree that that's a compound. Sodium chloride. You have sodium metal, chlorine gas. You combine them, you get sodium chloride. Would you call that a compound? Okay. Again, going down the checklist, does it have 2 or more elements? Yes, it does. Is it a fixed ratio? Now, anytime you see NaCl, it's always 1 sodium and 1 chloride. And it does have different characteristics. If you were to order French fries, would you ask for shavings of sodium followed by a wave of chlorine? No, that's very, very different characteristics than sodium chloride, which is wonderful and salty and crystal and white and tasty, right? So we look at that periodic table that you might be familiar with under chemistry law. About 20 to 25% of those elements are going to be essential to life. When we talk about an essential element, that means that's something that's required by life or required by the cell or an organism to exist. Carbon, hydrogen, oxygen, and nitrogen make up 96% of living matter. I was talking to the nutrition class yesterday and asking them, and somebody spoke up and he remembered CHON. CHON stands for carbon, hydrogen, oxygen, and nitrogen. So a lot of people just remember what 4 elements make up most of living matter. So if you were to take something living and you were just to completely destroy it into its original elements, you would find 96% of them would be carbon atoms, hydrogen atoms, oxygen, and nitrogen atoms. The remaining 4%, mostly calcium, phosphorus, potassium, and sulfur, and then you have what are called trace elements. Trace elements are going to still be required, but in very, very small amounts. A trace element does not mean that it's rare on the earth. Okay? When we talk about a trace element, we're saying it's required in very small amounts by living organisms. You look at what might be a trace element. Iron is a trace element. Do you think it's a good idea to take in large amounts of iron? You would not feel well at all, right? But could you go without iron? No, it's absolutely required, but in small amounts. Same with silicon and zinc and copper. But you can see that most 96.3% of the atoms that you're comprised of are going to be those original C, H, O, and N. For once in a while, I have somebody ask me, should they memorize this table? As people are trying to figure out, what do I need to know for the test? How many of you think memorizing this table would be a really good idea? You don't need to memorize the table, okay? If you're spending time memorizing the table, you're probably missing bigger ideas. Okay? How many of you think you should know the 4 elements that make up 96% of living matter? Yeah. Do you think it matters for every single trace element for basic biology? No. You should know what a trace element is, but don't spend time memorizing, unless you just like to memorize. Most of my tests tend to incorporate more than one idea, and so I want you to spend more time connecting ideas than memorizing large amounts. Okay?